We've looked at the convex lens ray tracing outside the focal length, so now let's do the other one. This is ray tracing for a convex lens with the object inside the focal length. Again, convex lens looks like this. I'm going to turn it into an ellipse just because it's going to make my life a little easier. Here we go. I'm going to start with my lens. And get some lines drawn in this thing. So, line down the middle. Let's go a little bit heavier. Line down the middle. Principal axis. And I want to count out some values. Alright, I have a focal length of 40 centimeters. There is F. And I'm going to call that 40 centimeters. Here's my reflection of F all the way back here. That is F prime. And I would like to put my object at the 24 centimeter mark. I know it's a little bit not a round number, but I'm doing it because I worked the math out and made sure that it comes out to a good location. Now I do happen to know I'm going to need a little bit more room over here on the left, so I'm just scooting this over. I'm going to put my object at 24 centimeters, and I would like to make this 4 dots high, 4 centimeters. 1, 2, 3, 4. I know that's a relatively small object, but I know it's about to happen, and I want to make sure to give myself some room. So F is 40. I've got my object height is going to be 4 centimeters. My object distance is 24 centimeters. That is the distance from my object to my lens. And now I'm going to start ray tracing. Ray number 1 goes parallel to my axis and then through F. So from here, I'm going to go parallel to my axis, and then I'm going to go through the focal point. That looks something like that. Ray 1. Ray 2 is going to go through F prime and then parallel. F prime's back here, so that's going to be interesting. But I can go through here to my lens and then leave on a parallel track. There's Ray 2. Problem. Ray 1 and Ray 2 are not going to cross each other. Because they're not going to cross each other, I want to trace these backwards, and I'm going to trace the outgoing ray backwards. So I drew an arrow on the end of my ray, and that's to kind of give myself a reference point. I'm going to go from the ray that I've got and just trace backwards as much as I need to. And then same story over here. I like to change the color just a little bit because it's a reminder of what I'm doing, of what's actually crossing. So this is my 2 prime. This is my 1 prime. And it's like 1 prime would have gone that way, 2 prime would have gone this way. This is if they were not rays that bent at the lens but kept going straight. That's pretty much what I'm figuring out. I'm taking the outgoing rays and saying, where did those come from? It's all the way back here. So now I have enough. These cross at this location, and I get an image. This image is not upside down, this is upright, which just means right side up. It is a virtual image, and it's a virtual image because I'm not finding where these light rays crossed. I am effectively finding if these were rays, where would they have been coming from? And that's way back here. So this is a virtual image, and it's bigger than my original image, so this is enlarged. My image distance is 60, but it's on the wrong side of the lens, so negative 60. My image height, I am right side up, so it's positive, and this is 10. Now I'm going to get rid of the dotted background, and we're going to take a look at what's going on. I have a couple of things I can work with. I can look at my magnification. My magnification, I said, was HI over HO. So image height, 10 centimeters over object height, 4 centimeters. I'm right side up, so this is a positive number, and that gives me a positive 2.5. Let's check it the other way. Magnification is negative DI over over DO is negative. D image is negative 60 centimeters. I've got DO is 24 centimeters. 60 over 24 is 30 over 12 is 15 over 6. And that's going to be 5 over 2, or 2.5. So my magnification checks out. I've got an upright image that's virtual, and it's enlarged. And now I can make a couple of quick summary statements. For a convex lens, what I had, if my object distance was bigger than my focal length, then I got a real inverted image. If my object distance is smaller than my focal length, I get a virtual and upright image. If my object distance is exactly equal to my focal length, then I get no image. There is a point where I can put my object right on the focal point and no image will be formed. I do want to add just a little bit more. This virtual upright image will be enlarged. For the real and inverted image, I get a couple of cases. Again, it splits farther, right? If my object distance is greater than double my focal length, then I get a reduced image. If my object distance is exactly double my focal length, then I'm going to get a magnification of magnitude 1. It's going to be inverted, so it'll actually be negative 1. And if my object distance is less than double the focal length, but I'm still outside, right? So I'm still between those, then I get an enlarged image. That kind of summarizes what's going on with convex lenses and image formation, and hopefully makes things pretty clear.